So, Cloud Native Infrastructure by Kris. That's me. Clicker, click. OK, cool. So, I'm going to tell you a little bit about me. I love Linux. It's kind of a big deal. I've loved Linux since I was like 12 years old, and I loved it so much, I installed it on our family's computer, and I nuked all of my parents' tax information, and they effectively grounded me from using Linux for like the first 4 years of my high school career. I still use Linux, though, which is weird because I work for Microsoft, and you're like, what are you doing running Linux at Microsoft? But that's my jam. In fact, that's what I get paid to do. So I work on Azure, which is our cloud. So I'm sure most people here have heard of it. Show of hands, who has used Azure in production before? Nice, nice. So I'm an advocate, which means I get to talk about Azure and help you out. So if you ever have any problems or you think Azure can be better, feel free to hit me up on Twitter or any of the Slack channels I'm in. I think I'm in like 34 Slack channels right now, so it's getting kind of out of hand. So I created this tool called Kubicorn, and I'm really great friends with Ashley, who drew me a really wonderful logo. And it's a concrete example of this thing we're going to be talking about today, which is cloud native infrastructure. And I would love to talk more about it after my talk if anyone is interested. Also, I write a ton of Go, which makes me a gopher. Or in my case, I also am a Kubernetes maintainer. So a lot of what I do is help out the community and work on this infrastructure layer of Kubernetes. So again, show of hands, who uses Kubernetes or has used Kubernetes in production? Come on, put them up. All right, it like gets bigger every conference, so I really love like checking that number out. It's kind of interesting though, because looking at Kubernetes, if you go back in time and you talk to the founding fathers, who are some good friends of mine, they intentionally said that the infrastructure layer is out of scope, meaning we're not going to care about it in Kubernetes. But like here at HashiConf, like infrastructure is like, that's our jam. That's what we care about. We're ops people. So a lot of what I have sort of decided to do, because I'm such a rebel and was running Linux against my parents' will my whole life, was solve this infrastructure problem for Kubernetes. So that brings me to this question. What is cloud native infrastructure? Well, it's infrastructure in a cloud. But like literally though, hold on, I got more to this, I promise. OK, really, it is. OK, so what is a cloud? A cloud is this magical place that exists in some data center you and I will probably never know about or probably never visit. And you can look, and I found all of these wonderful cloud logos that just all ironically happen to look the same. And I think if you go out in like the speaker, or not the speaker, the main area, like all 4 of these booths are like right in a row. So like the cloud is a big deal. If you haven't got the memo yet, it's really, really taking over. So what is infrastructure? This is what I think of when I think of infrastructure. Is this like noisy thing that as a software engineer, you're like, man, I just wish this was solved. And then we have all of us who are like dealing with all this noise of managing infrastructure and coming up with cool and clever ways of making it work and work well, which is why HashiCorp has been so successful. But like, why is it better in a cloud, these clouds? Well, if you want to manage your infrastructure, now it's an HTTP request, which is kind of no big deal, but if you actually think about what's going on there, it's actually giving us a really interesting way of looking at managing our infrastructure. And coming from someone who worked in data centers, an HTTP request is much easier. And I think this next slide actually says, like, how do I know? Because I worked in a data center, bro. Like, I literally used to drive down to the center, and like they had these things called snips. And I would like have to like cut a cable and like undo it and like find like the little wires and stick them in a jack and then like crimp the jack and like hope that fixed our problem. And that was my job when I first got into software engineering. And I remember like coming home at night and like dreaming in bed like, man, one day I'm going to be a software engineer. And it's like totally going to happen. And then like get up the next morning and go polish some fiber or like fix a switch or something. So I helped write the book on it. But like, no, literally, like I really wrote a book on this. And it was really hard. In fact, my co-author, he's here somewhere, and I'm going to really embarrass him right now. Justin, can you please stand up? And can we give just a big round of applause for Justin, everyone? So writing this book was like, I got into it like, yeah, I'll write a book. And then like the actual implementation came around where it was like Friday night, it's like 10 o'clock, I'm like ready for bed, I'm in my pajamas. And like Justin would message me like, hey, you ready for a call and ready to start writing our book? And I'd be like, damn it, like I really just want to go to bed right now. So it took us a couple of months, and I will say that this guy is a machine. I would just watch his commit logs like go through the weekend and just cranking out like nonstop quality stuff in our book, and it really, really helped me to get inspired, like seeing this kind of work. And the guy has a freaking family too, and I'm like, I don't even have that. Dang, like, he's running circles around me right now. So anyway, thanks to Justin. Okay, so cloud native infrastructure, like we talked about this, it's like this idea of everything's in a cloud. So with everything being in a cloud, those HTTP requests are how you're managing it. And I'm kind of going in circles here. But it's really interesting to compare that to these like traditional infrastructure. So what we're going to do is we're going to really quickly go through like some examples of what it's like cloud native versus not. So, oh God, I love these pictures. So like, these are like super crazy stock photos I found, and I just really think they're great. So every time I see this dude, I'm like, yeah, you go, dude. Like, plug these cables in. So anyway, so like this was me at the data center. Obviously not a dude, actually, well, yeah, anyway. So setting up a network in the field, and that is this guy here. And then it's like, oh, sweet, we have this curl command. And like, if you actually look, there's some JSON up there, and you're like, oh, I'm changing some fields in my JSON. And like, poof, I set up a network. And and this could be in Azure, this could be in Amazon, like this could even be in a cloud of your own design if you so chose. And then we can go and like this girl, just my home girl right here, like provisioning a switch. Actually, I don't even think she's provisioning a switch. I think she's like plugging in patch cables. But like, this is really like strikes a chord with me, because I used to actually go and like have to make all these teeny tiny labels for all these cables going everywhere. Yeah, he's laughing right now. He knows what I'm talking about. It's so annoying. And I like remember like that was like I was like the good one who like print this thing out of a little tiny label maker and like have to go and just like barely put it right in the perfect spot. So anyway, now it's a curl request, which is great. And then you can see here, like, oh yeah, cool, like a subnet mask. Like I just pass it in as a string. If anybody's ever provisioned a switch before and like got the serial cable out and had to set their baud rate and like had to go and actually use like real iOS, not Mac iOS, like the real one, the first one, they know that like setting up a subnet is not this easy. So back to this guy. Oh, I went backwards. So provisioning a switch in the cloud, curl request, and then we have this guy with our Fluke tester, which God, I had like 4 of these, and I used to be so proud of them, but now they're like kind of embarrassing. But yeah, like if you had a problem in the field and you didn't know how to fix it, you would like drive to the data center. In fact, I remember when I was working at my second job out of my sad attempt of a college career. And there was this guy who's like, yo, dude, like our server's going down. We can't fix it. And it keeps going down like every night, and nobody knows what's going on. And it only goes down for like 20, 30 minutes, and then it comes back up. And it's been going on for 6 months. And we're like, we have strace out, and we have nmap out, and we're Wiresharking, and we're like trying to like look at the kernel and see what modules are installed. And we're really like, we're gonna get this, we're gonna get this. So finally, they're like, you know what, Kris, we're gonna fly you out to Kansas City, Missouri, and you're gonna have to go and figure out what in the heck is going on with this server. So they flew me out there, and I like walked into the data center, and I start hacking. And I'm looking, and I'm doing the same stuff I was doing back at home, but now it's like in a data center, so it's like, and it's like super cold, and I have like my hoodie on, like just like sitting there in a little tiny like milk crate or something, hacking away. And like anybody who goes to the data center, it's really easy to lose track of time, because it's just like super bright Walmart fluorescent lights in there. So next thing I know, it's like 12 o'clock at night, it's midnight. And a cleaning crew comes in. And the guy walks by the racks, and I notice that when he's like sweeping the racks, he's like going up underneath the rack. And I'm like, no way, no way. And so I go and I look, and there was somebody had like rigged up like a surge protector right there by the bottom of the rack, and it was just sitting there under this huge pile of Cat5 cables. And the guy would come and sweep every night, and he would just touch that surge protector just enough to like wiggle one of the power receptacles loose, and the server would reboot. And I tested the theory. I was like, hey, can I borrow your broom for a second? And I just swept the floor, and then like hopped on my computer, and like I could replicate the problem. So I plugged it in, and we like told like, guys, you got to get the surge gate off the floor. Let's like get some real power in here and fix the problem. So anyway, that's my story about diagnosing a problem in the field. And then of course, to carry on with suit, like diagnosing in a cloud, it's just a curl request. It's so much easier. So no more flying out to Kansas City, Missouri, and taking care of all of these mysterious, whimsical bugs that I used to have to deal with. So these buttons are like hard, I keep going the wrong way. Okay, so TLDR, it's all HTTPS. And like it should be secured, but like really it's just the HTTP protocol. Good old HTTP, my jam. Show of hands, who's read this thing? Yeah. Let's hang out after this because we're like gonna be best friends. So this is like the first RFC to the HTTP protocol. And how this thing like sort of came to be is like, I imagine like Lord of the Rings, like they're all sitting around like, today we will write like the protocol that will run the internet for the rest of our lives. And all this does is it's just a bunch of words like written by humans for humans. It doesn't like really necessarily do anything. It's just like a spec. And it says like how humans are going to interface with computers. So we said, OK, so we're going to define these methods, and you can expect a computer to rationally behave in the following ways if you send this type of message over an open socket. And if you've never done this before, go on your computer, open up Telnet, like good old, like not SSH, like Telnet, and Telnet into like Google.com or Microsoft.com, and like type out a GET request, and you'll actually be able to watch the server like acknowledge your GET request and like send it back. If I have enough time, I'll do one at the end of the demo here. So what are we using this protocol for? Well, we use it for mutating systems and reporting status, regardless of the system. Regardless of if it's for infrastructure or not, this is what we do. Like if you're hitting the Amazon API to buy a book, you're mutating some data set, and you're going to get some status back. And it's going to say, like, dude, things went wrong, or like, oh shit, something went wrong. Like, we're going to have to figure that out. But HTTP is how we decided we wanted to interface with all this. So going back to this cloud native idea, if everything is an HTTP request, then like we can start to make these like really cool concoctions of software. So how do human beings think about this stack? This is the OSI reference model. And when I had to get my CCNA, I had like literally almost got this thing tattooed on my back. Like, OK, so honestly, show of hands, who knows all 7 of these by heart? Yeah. Same guy who read the RFC. Also my new best friend. OK. So yeah, it starts at the bottom, and it works its way to the top. And we're going to kind of break it down. And I'm going to explain like these 2 sets. So this top one is like application land, which we don't care about that. That's like software engineers, and like we don't care. Yeah, like cute application, bro. And then there's like this other layer called infrastructure. And that's like what all of us here at HashiConf care about. This is why we're here. And if you look, we go from physical, which is like me literally flying to Kansas City, Missouri to like discover that some piece of copper was not correctly touching another piece of copper. And that's what was like causing the problem. Like literally electricity was not flowing, and I had to go fix that physical layer. And then it like goes up across data link, which is how you plug stuff in, the network, which network guys, who cares, and transport, which is how we like traverse things over the network. So this is the way human beings have always thought about the stack. And there's like this like sort of like good versus evil like Star Wars battle thing going on between applications and infrastructure. But like we're in a new world, and this model is outdated. So the new OSI reference model. I am killing it up here right now, you guys. Like, this is great. OK, so yeah, this is all HTTPS stuff. And what it does, we really don't care about. And then there's like this weird other stuff that we don't really care about down there at the bottom that somebody else can deal with. But this is the new way we think about things, which means the network, those switches, your virtual machines, your load balancers, it's all software now. Or at least it should be, which is the point of my talk. Everything is now software. Software is software. Things you didn't think were software is now software. Like we're building robots that run on software. We have cars that run on software. It's everywhere. So how do we manage this? And when I say this, I mean infrastructure as software. Like what does that look like? You're like, OK, cool. Like I would like to go write software today that manages infrastructure. And how would like I start thinking about that? Well, first we have to represent. Like infrastructure people are the best. We all know that. But what we do, and whether or not we've realized this or not, is we always represent infrastructure in some way. And then we go and we do something with that. So let's take a look at the history of how we've been representing infrastructure over the past, 20 years or so? Number one, infrastructure as a diagram. Look how empty this diagram is. I have no idea what's going on up here. Somebody thought it was a good idea to run FreeBSD. I think there's a virtual machine. It might be the same one. Hey, at least we know what version of the operating system we're running. And then there's this weird cloud with some arrows that means something. Data probably goes there. I don't really know. Oh, and then look at the bottom. There's a CIDR address and subnet mask. So it's I guess that's a network, maybe. So I remember my first job, my first day on the job working at a data center. I walked into my boss's office, and I'm so nervous. I'm oh man, I have no idea what it's going to be like. What if I mess up? What if he asks me to recite the OSI reference model and I get it wrong? And he walked up to a dry erase board, and he starts to draw a picture. And the guy smoked 2 packs a day and was get on down to the data center and go do that. And that was my job. And at the time, that was just work. But then looking back on that, he represented infrastructure by drawing it on the dry erase board. And then I went and created that infrastructure based on that representation. So, wrong way again. OK, infrastructure as a diagram. So adjusted annoyance ratio here on the right, I just made that up. There's not a real metric there, but I'm just trying to demonstrate a point that as an engineer at the time, a data center technician, it was really annoying to go and try to take this guy's really weird representation of infrastructure and go be confident that I created it appropriately. But the good news is my boss only had to spend 5 minutes drawing it on the dry erase board because obviously he was too busy to go into detail with me. Next, infrastructure as a script. Show of hands, who here has written a bash script? If you don't raise your hand, get out. OK. We've all done it. I love bash. Bash used to be my first favorite programming language. Now it's very closely on the second. So here's a bash script. No, that's not a real key, so don't ask. I changed 1 character in there, so it's not going to work. So yeah, let's take a look at it. Can you guys all see this OK? OK, let's take a look at this. OK, so pkg install bash. OK, so obviously we're running on FreeBSD because we start with born again shell because that's a thing. And we do curl minus capital L. We're installing some Azure CLI, and then we need to log in, and then it looks like we do some az group delete, az group create, and then we do something else with a virtual machine, and hey, there's an SSH key. Cool. We all know what this is. If I gave this to you and said, tell me what this is a representation of infrastructure, as well as the way we would create or provision that infrastructure. But you need to have that sort of fundamental paradigm break that this actually can be used to hey, what does your bash script do? Show source code, and other human now understands what your bash script is doing. So this was actually a really beautiful thing. But let's look at our adjusted annoyance ratio again. So that bash script took me about 25 minutes to write. I had to look up how to set something, and that took 10 minutes of looking at Stack Overflow. And then you can notice that our adjusted annoyance ratio has gone down quite a bit. So you're starting to see this exchange and how much initial effort you're investing into your infrastructure, and how easy it is for something or someone to go and reconcile that infrastructure and make it so, or provision it. Infrastructure as code. Terraform. Show of hands, who's used Terraform? OK, same rules as bash. So Terraform is beautiful because you can define your infrastructure as code, and you can create these really powerful templates, and you can pass them around. And it has that same paradigm as bash, where bro, what infrastructure did you create? Bro, here is my Terraform config. Right here, take a look. So we've all used it, and we've all been doing it for a long time. And I really think that with new tools like Kubernetes, we can take Terraform and really, really run with it and really, really make it grow. So this is the new way of doing things. And when I was writing this book with Justin here, we got Mitchell on the phone, and we had a one-on-one. And Mitchell told us this amazing story about how Terraform and infrastructure as code came to be. I'll let him tell the story himself, but it really like opened my eyes to this idea of like there was this awakening. There was this like sort of like, oh, aha moment. So anyway, looking at our Terraform configs, we're now doing significantly better on our adjusted annoyance ratio. I wish that acronym was like more funny. I really do. But it took us 2 hours to write. But again, that's an investment. Because now I've invested into Terraform. Terraform is a statically linked binary, so I know wherever I run it, it's going to be ran well. I can interpolate at runtime with whatever configs I want to override. And I can now easily describe to another human what infrastructure we're creating. And there's like this huge, awesome, amazing underlying graphing library that will actually go and like do all the annoying work of like checking what's there and seeing what we need to create and oh, there's a delta and let's go and like manage that. And that's beautiful because as like a data center technician, I would have to go do that, but like as a human. But now we're doing it as software, which is pretty dope. Infrastructure as software. And really, infrastructure as software is just like a little teeny tiny extension of infrastructure as code. In fact, that's literally how I think of infrastructure as software. So for those of you who don't write Go, a for loop without any parameters just is like while true. So this is just like a loop that's going to go on forever and ever and ever. And that's just a comment that says run infrastructure as code. So then we can look at that on expert mode, which this is that same inside the for loop is what Terraform is doing, which is we're doing an audit, what's there, and a reconcile. What work do I need to do? Let's make sense of that. Look at that adjusted annoyance ratio, ladies and gentlemen, 10%. Again, I made these numbers up. But it took us like 6 months to get here. And it did, because I actually tried to do this. We'll get there in a second. So I'm going to tell you another story about this sort of cloud-native application bit of things. So infrastructure as software is cool. We understand that we can run it in a loop. But like, what is cloud-native apps? What does cloud-native really like mean, and what does that mean for software engineers? You know, those people we don't care about who like write the cute programs? I had to write those cute programs for a while, so I had to learn how to write these like really powerful cloud-native apps. And while I was doing that, I was interacting with some of the most brilliant minds in the industry and watching how they were solving these software-level concerns. So, the CoreOS etcd operator. Who here even knows what this means? Nice. Kubernetes folks. So what the CoreOS etcd operator does is I'm not going to go into super great detail of like how all the containery bits work, but there's some high-level stuff here that you guys need to understand the pattern for. So you schedule an operator pod, which this is like fancy Kubernetes talk for run a container. And the container runs a little bit of software. So think of that software as one of those while loops, looping over and over and over again. And scheduling just means we created that. It would probably be safe to say, like, you could imagine that a person sat down at a computer and ran a program, and that program just runs indefinitely. And that's really all that Kubernetes is doing for us under this, like behind the scenes, but like in a container, in a pod, with a service, with a deployment, and all this like Kubernetes stuff. So after that initial bit of software is running, then it brings up the etcd cluster. Then it brings up the etcd cluster. I'll say it again. Then it brings up the etcd cluster. So we have software that manages other software, meaning you had to start something, and it said, oh, dang, nothing's running. I better go like create something. And then all these folks over at CoreOS said, we can put in these really, really powerful bits of logic that says, like, what operating system are you running on? We'll have to like treat the etcd cluster a little bit differently because of that. Or like, how big, how much RAM do we have? How much memory is available? How does our CPU usage look like? And they can build this really, really mature application that all it does is starts other applications internally. But it's this idea of like bootstrapping apps with an app. So seeing that, that was kind of like mind blown, like, wow, that's such a great idea. And it's software as software. Because really that's what it is if you look at the etcd operator code, you'll see that we're just representing more software with the initial software. Wow, I just looked at my time and I'm like super rushing. All right. So I think we should learn from Kubernetes. I think we should learn from these people at CoreOS. I think we should learn from this community that has, some of the brightest minds in the industry all working towards making these really powerful tools. So this slide, this took me 2 weeks to write this slide because I really wanted to pick each word carefully so that I could really just say it. This is what Kubernetes does. And I get asked this Kris, what is Kubernetes? And I'm like, dude, camp out. We're going to have to spend a whole night talking about this thing. But on one slide, in 2 really, really easy sentences, you declare a state, and software reconciles that state. That sounds familiar to Terraform. So a Kubernetes controller or a Kubernetes operator, pretty much safe to say those are the same things. They follow these software patterns, and they go and they reconcile state in the same way that Terraform reconciles state, except we're doing it as applications. So I'm over here saying Terraform's the OG, and you guys are just ripping off Terraform. So I had come up with this fun little pattern here. We had this in Kubernetes kops, which is an infrastructure management tool. I have it in another tool I wrote called Kubicorn, and I've used it for many, many other things as well. And this is sort of it boiled down to the meat and potatoes. 4 simple methods. And so you have a method that its entire responsibility set is to go and get what is actually there. In the context of infrastructure, those are HTTPS requests. Let's just go see what's there. Then we have get expected, which goes and will actually say, based on some arbitrary input that we got from some human with a neckbeard, what do we want to create? And then we have this method called reconcile, which is where you give it what's actually there and you give it what you want. And then ideally, it makes sense about the two and it goes and reasons about it. And you see this pattern in Kubernetes, and you see it in a lot of software applications. And I'm like, let's really, really start opening up this idea of auditing and then enforcing. And then there's destroy, which you just nuke everything RMRF. That one's easy. Cool pattern, bro. Hey, I worked hard on it, OK? And I use it a lot, and it didn't always look like that. In fact, that took me a year and a half to kind of get it boiled down to those methods and get to a point where it works over and over and over again in a lot of different concrete ways. So looking at an implementation in a Kubernetes controller, this is pretty much as simple as it's going to be. Tell me what's actually there. That's what that first line's doing. That's lazy assigning Golang, which just think of that as a regular assign in any programming language. And then expected does the same thing, get what we expect to be there, and then go and reconcile, and just do that until the end of time. Realistically, this loop is going to be a little more complex. We'll probably want a signal handler so that you can send signals to it to make it die politely or whatever. But that's the high-level pattern of what you're going to see in these controllers. Oh, man, the bootstrap problem. OK. So pulling away from controllers, you guys are all good on controllers. You all have this idea of what they are. There's this really, really interesting problem with infrastructure folks that we get to solve. And I call it the bootstrap problem. But the high level is applications run on infrastructure. And I'm sitting here telling all you guys to write apps to manage infrastructure. But which one comes first? Where does that initial cluster come from? Where does that initial bit of infrastructure come from? Terraform solved this problem by running everything locally, and then making the assumption that whoever's going to start creating infrastructure has a computer, and we can run a statically linked binary on it. But there are many other ways of looking at solving this problem as well. And I would like to take you guys on a quick journey through the past to tell one of my favorite stories ever about one of my heroes. So show of hands, who has heard of any of these acronyms before? Awesome. So these all came from the GNU operating system. GNU is not Unix, and it's certainly not Linux. And that's my GNU operating system slide, because I'm here to represent true open source software. But why am I telling you guys about GNU? Because they were able to solve this bootstrap problem, but in a different way. So let's look at GCC. Who here has written, for real, who here has written C? OK, me too. So you're all familiar with GCC and linkers and writing makefiles that are 1,000 characters long and trying to debug oh my god, there's some freaking seg fault and I have no idea why, and I have to go through line by line by line. But where did the GCC compiler come from? My man, Richard Stallman. God, I love this guy. He really is one of my heroes. So for those of you who don't know, Richard Stallman is this notorious dude who travels around with his laptop, and he helped father in Emacs, the best text editor, and he helped write, well, he did in fact write the first implementation of GCC. So I'm not going to bore you guys too bad, but I really, really wanted to like show you this letter. And if you look at the top, this is from March of 1987. And I'm going to skip down to the bottom here because the first part is just like, yo, dude, I wrote some docs. And then it's like, this is also contains the ANSI standard from November of 1986 of the C preprocessor and 30 pages of reference manual for it. Moving on, we see this compiler compiles itself correctly on the 68020 and did so recently on the VAX. It recently compiled Emacs correctly and on the 68020, and it has also compiled text in C in Kyoto Common Lisp. However, it probably still has numerous bugs that I hope you will all find for me. That's just like how Stallman rolls. I love this guy so much. I'll be away for a month, like in my mind, like reading this as like a kid. He's like going on some extravagant vacation, like after the GCC compiler compiled itself and like flying away, like yeah. And then you like go deal with my bugs, LOL, love RMS. So the first compiler, that's such an interesting question. How did that work? Who here has ever compiled a compiler before? Did you cross-compile it? Probably yes. But that first compiler had to come from somewhere. Like we didn't just wake up one day and like the human species had a compiler. So I'm going to tell you guys this quick story about my homeboy Dave, who I used to work with at my last company. And Dave he's from Texas here. Which is cool. I didn't realize that until just now that I was going to be talking in Texas about the story from Texas, which I was born here too, so it's all like full circle. So I remember like we were talking about this one day at work, and I have no idea why it came up, and Dave was like, oh, we used to do this in college. And this guy worked on the original TI-83, and he used to write the assembly code for these graphing calculators. So we've all used one of these calculators before. I know. I'm not even going to ask you guys. Like I know we have. And he like helped build these, and that was his job at Texas Instruments. And so Dave was like, oh yeah, we've done that before. And I was like, okay, so what was it like? He was like, you just get a little bit closer each time, and you just keep running it, hoping for the best. And like that was how they compiled compilers without cross-compiling. And I was just like, what do you mean? And then I started to kind of think about that. And like imagine like the first time you run it, you get a little bit of binary code that can like do something. And the next time you run it, you can use that binary code to like further mature the other bit of binary code. And then eventually, if you structure everything correctly, at the end of the day, you have GCC, this like crazy complex compiler. And it's just like, whoa, they had to solve that problem in the 80s. And like we're over here like complaining about HTTPS, like wow. So should we do that with infrastructure? Absolutely. We're going to have to come up with really, really clever ways of how we're going to look at our infrastructure and how it's going to be created and how we're going to bootstrap it. Because we're in this new way of doing things where like if it's not automated, you don't care about it. And even then, there's now like this whole evolution of automation where it's like if it's not in like Kubernetes in a pod running with some like controller, I don't care about it. So we're going to have to figure out ways as infrastructure engineers to like figure all this stuff out and make it like happen at the click of a button. OK. Whew, this is where I'm going to get nervous. I have 7 minutes, so I'm going to try to go quick. So I got bored over the weekend, and I wanted to show you guys this concrete example of infrastructure as software. So last weekend, I do a lot of climbing, like I was introed with. And instead of climbing last weekend, I decided that I was going to run Terraform inside of Kubernetes as a controller. So I actually got this working like an hour ago. And I'm going to be able to cancel here and demo it. Let's see. And we're going to do like the cooking show thing where I like run some commands and then poof, the turkey's done. So let's go over here. And I don't really know how I'm going to demo this, but we're just going to take a look. Can you guys all see that OK? So I created the repo. It's open source. It's right there. It's called Terraform Cuddle is the name of the repo. And this is an example of it running. Over on the right, we see some logs that we're going to go into. And over on the left, we see this command I'm going to explain in a second. But basically what happened is I took Terraform, and I stuck it in a for loop, and I stuck it in a container, and I scheduled it in Kubernetes. In that for loop, I also wrote a gRPC server. Who here has used gRPC before? It's great. It sounds intimidating, but it's so easy and so much fun. Like the first time I interacted with gRPC, I was like, OK, this is going to be real. Like, I'm going to have to really learn this really crazy complex protocol. And it's not. You like go define a function, it generates some code for you, and you're done. That's it. And it just works, and it works beautifully, and I love it. But basically, all it does is it allows you to transmit data natively from your language into some server on some network that we don't really care about. So over on the right, we're actually running, and let's see if I can stop this. Kubectl logs. What? OK. And then we want, actually, let's do this. Let's do kubectl get pods. I don't know what's so funny. So we have this pod here, and I'm trying to like drive on this other screen, and I only got 5 minutes, so bear with me. We're going to try to go quick here. OK, so now I can do kubectl logs and just paste in the name of our pod. Poof. Oh, and we want a -f on the end, so we can follow that. OK, so that's Terraform. If you've ran Terraform in the last like day or so, that's what it looks like. And then we have this other tool over here. Where's my mouse? OK, called Terraform CTL. And this is like, oh, it doesn't look very good there. And there's like this, oh, it's going to look horrible. Maybe I should full screen this. I'm going to do that. Terraform CTL. Hey, that looks pretty. And it's just a command. And all it does is you can get, and you can set, and you can serve. You run serve, it runs a gRPC server, and it runs in Kubernetes. You type set, and you give it any Terraform configuration you want, except for now, we have all of these bells and whistles of Kubernetes. I can get Prometheus on this. If the pod breaks, Kubernetes will reschedule it. If I want to check out the logs, I can kubectl get logs, or I can do whatever awesome logger I want. I can run a replica set if one of these things goes down. And we're using Terraform and all of its beautiful goodness and its ability to reconcile infrastructure in a pod. And I think that's really cool. So I have this example code here, and I am going to run Terraform CTL set, because we're just going to set something. And don't ever use this in production. This is like me hacking on a weekend. So this is not like production code. I just want you guys to see this idea. So then you like pass in the name of a Terraform config, -f. And oh, where am I? Let's go source GitHub Kris Nova, Terraform cuddle, and set -f examples Azure virtual machine scale set. Ah, damn it, didn't work. Of course, this is my luck. I promise it was working earlier. Something's going on. Let's look with our pod here. Actually, we can go right here and check this out. K get svc. Ah, I know why it didn't work. I got to tell it what server to talk to. Derp. It'll default to localhost. So there's no gRPC server running on localhost. Let's do that. So now this will work. Yeah, it worked. Yes. I was so nervous. Like, you know when your demos don't work and you're like, oh, man, what am I going to do? OK. So anyway, go back here. And it wasn't as cool because you didn't really get to see it. So I'll run it again here so you can see the side-by-side. Terraform cuddle set -f examples. We'll create another virtual machine scale set, and we'll paste in our host. And if you look on the right, bam, Terraform. How cool is that? Running in Kubernetes. Come on. That was cool. OK. So again, like, this is super hacky. If you go look at the code, like, I had to do some really, really ugly stuff to get this working. But I wanted to show you guys this idea of, like, hey, we can write infrastructure apps. Like, we can do that. That's a thing. And in fact, we should start doing that. So let's get my slides back up, and I'll close with 1 minute here. So present. And then I have a blog on this, so I'll like tweet that out, and you guys can like see how to run this and like look at this idea of using gRPC to like control infrastructure. OK, so there's the name of the repo. This is a quick little diagram. Notice C:/, props to Microsoft. gRPC, running Terraform in Kubernetes. So let's check out the super dope app. I just showed you guys the super dope app. And this is like, tweet this slide, somebody, please. Like, this is so exciting that we can run Terraform in a pod. And we did all that running on Microsoft Azure. This is the slide. My bad. I'm getting rusty, and I only have 50 seconds left, so bear with me. So what's this lesson here? I'm going to bottom line it, and then I'll get off the stage, and you guys can finish your day. I know we're all tired from being after lunch. But stop managing infrastructure this old way, and start looking at like this new idea of writing cloud native applications to manage cloud native infrastructure. And then it's really exciting because like I literally had to hack something together over last weekend just to give you guys an example of this. Nobody's doing it yet. Like people in this room can go home and start writing these containers and putting them on GitHub, and they like solve infrastructure problems. And like you will be the first one. You get to have like all the GitHub stars. You get to be the famous person on Twitter because nobody's doing this yet. So sorry, bro, you are now a software engineer. So more than anything else, what I want you guys to know is it's OK and it's safe. And please, 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 please start writing super dope cloud native infrastructure apps. Kris Nova, thank you.